Okay, so let's make a start by actually going right back to the very beginning and having a look at what makes a digital image different from an analog film one. First of all, we need to think about just what is digital. So the real world around us, all the things we see and listen to or whatever, are all analog. Paintings, photos, music, sounds, everything really is analog, and everything made by nature is analog itself. And analog means that it's a continuous gradation from one extreme value to the other. So if we're talking about an image, this means it's just a continuous change from the darkest black to the whitest, brightest white. And there's no borders, but it's a continuous thing. And digital means that we're actually going to start putting some values into that. So a digital a value is created by a computer, which has to be worked down in terms of numbers. A computer can only really think of in terms of a number. So in this case now, instead of having a continuous set of values, we've actually said there are 8 values here. We've numbered them 0 to 7, and that has given us 8 shades of grey. For us, often the real challenge is moving from the real world, that 0 to however many it was, the continuous shades of black through to white, through to the computer's 0 to 7. And this process we call digitization or digital capture. So in the real world, as we said, if we think of it in terms of a graph, the gradation from black through to white is totally continuous, and there are as many values, an infinite number of values between the black and the white. But if it's in the virtual world and it's a digital image, then now each one of these values has a value. So there are a particular amount of values between black and white, which we can see in that gradation there from black through to white. So when we start by actually taking an image, and we take that, and here is an image. If we, in terms of actually photographing it, or maybe it's easy to think of it in terms of scanning it, but it comes to the same thing, what we're going to do is apply a grid. So if we do that and we apply this grid, I'd like you to think, what will we actually see in each one of these cells? Have a think about it for a second. The answer is that each one of these cells will be averaged out, so we can't actually see much detail in there at all. So if there are only 6 pixels, there really isn't much of an image. As we build it up and put more pixels in, then each one of these pixels is showing the data from the image behind it. When we get to 64 by 96 pixels, we're beginning to see some semblance of an image there. And as the megapixels go up, as the resolution of the image goes up, so we can see more and more detail there. So that explains how the images actually becomes better quality by there being more pixels in it, by that grid becoming smaller and smaller and smaller. So which is why we really are impressed when somebody says a camera is a 24 megapixel camera rather than a 12 one. But the next point is, what is the information that is held by each one of those pixels? Now, a computer has to use digital values, and that really means it can only use a set of switches, where either on or off. That's all a computer at its most basic can tell. So in terms of an image then, it is saying that an image can either be black or white. If there's only one bit of information, then that one bit of information can only say whether the image is black or it's white. If we then change it to having 2 bits of information, now there are 2 switches, and those switches can both be off. You can have one off, one on, one off, or them both off. And this gives 4 potential different values, which means we can have 4 shades of grey, and this is what we would call 2 bits of information. If we go up to 4 bits of information, then that can give us 16 different values, because there are 16 different potential values using 4 characters. This is, as you might recognize from your school days possibly, is binary, and what the computer is able to work, what the computer works in. So as we go up then, so each number, each bit value is a set different amount of different values. So we normally work with what we call 8 bits, which gives a range of 2 to the power of 8 or 256 values, different values of that color or that channel. Which is why we get the values, and you've ever wondered in Photoshop why they read from 0 to 255. That is the 256 values, which is 2 to the power of 8 or 8 bits. So each one of these pixels in this image has a value. And if it's 1 bit, then it could only be black or white. And we would see just an image which was made up from either black or white. If it's 8-bit, then it can be grayscale. So then we can have 256 different values of black or white, or any of the values between the two. Or we could make 256 values, but they are specified values. If you look at the quality of those, the image is not great quality because there's only a limited amount of colours that are available because they've only chosen 256 different colours. What we normally use in our cameras is what's called 24-bit. This is 8 bits in each one of the colours of red, green and blue, which gives the potential for 16,777,216 colours, which should be enough for most of our images. It is possible, and you'll see sometimes cameras and scanners claiming to have systems which use more colour depth than that, up to 16 bits per channel, which is normally called 48-bit colour. So it's worth remembering that the quality, therefore, of an image is based up, first of all, by the number of pixels that are in it. The more pixels, the better the quality. The higher amount of megapixels, the better quality the image will be. But it's also really important to just be aware that each one of the pixels has a value in it in itself. And the more possible values, the more wider selection of different colours, then again, the better quality. If you have only 256 values of grey, then it's going to be a black and white image. And the accuracy of those values in each pixel and how accurate they are, that is what is going to make the quality more important. So when you talk about digital quality, it's these strings. How many pixels, what variation, how many different colors can those pixels hold, and how accurate are they?